Hello everyone and welcome to this video. In this one we will learn about custom targets. And a custom target is a target that is different from the usual targets we have seen before, which are executable targets and library targets. A custom target is a target that can run any binary to do any kind of task you can imagine. You can run a utility to encrypt your files. You can run a utility to download files from the internet. That's really what you can do with a custom target. You can think of executable and binary as special types of custom targets because really the executable target is meant to run your compiler to generate your binary. The library target is meant to run your compiler to generate a library, and really the binary that these executables run is your compiler, be it MSVC, Clang, or GCC, or any other kind of compiler you might be using. So we will see how to set up a custom target, and our custom target is going to be specialized to format our code. And in C++, there are many utilities you can use to format your code, but CMake-Format is one popular option. You can use it manually on the terminal by running the command like this. So you say CMake-Format and pass the I option, which is going to format your code in place, and you specify which style you want to use to format your code. If you want to learn about these styles, you can open up your browser and look at Google C++ coding style, Google C++ coding style, and you can learn all you want about it. This is one style. You can look at the LLVM C++ coding style. Okay, these are some styles that you can use. And there are many others. You can read the documentation for CMake-Format that I am going to share in the description of this video here. So you just have to choose one. And I have to say that these coding conventions or these styles are just a base on top of which you can build your own. So you can say, I am using the Google style as a base, but I am going to customize it to do something that is specific to my needs. So that's what we will be doing in this video here. And again, the main point is to teach you about custom targets, and we will be using CMake-Format as an excuse. Let's go into our editor. So here is the code we will be using to learn these things. You can get this code from the Git repository. Starting from now, I won't be typing things line by line because that's time consuming. And if you made it this far in the series, you already know a lot about CMake. So you're not a beginner anymore. And we are starting to touch on some really practical topics. That's what we're going to do here. So this is a project we have. You see we have a root CMakeLists.txt file. It is going to set up our project. We have a version here, and we are setting up the C++ standard. I chose to use C++ 23 at this moment. C++ 23 is starting to get good support for compilers. We are in December 2023, so this is a good time to try it out. So why not? CMake supports it. We're going to use it. And we have an executable named Rooster, which is going to be using these two files. We also set up an include directory, which is going to be tied to this target. We want to include any header files that are located in the current source dir, the location of this CMakeList.txt file. And don't worry about what we are doing here. We will explain it later, but you can see that it is a simple CMake project, which is made up of 3 files: person.h, which is our person class, person.cpp, which is the implementation of our class, and the main cpp file, which is really going to bring everything together. It is going to include the person header. It is going to create a person object, and it will try to use it. You see, we are trying to print the information about our person object here. So what do we want to do? The main goal is to format the code automatically, but we will start by doing things manually here. You can see here that I have put my curly brace on the first line where I have the header of the function. Some people say it is good to put curlies on the next line. Some people prefer the curlies to be here. Some people put tabs or a few spaces before statements in their code blocks. There really is a million ways you can format your code, but we need one consistent way to format the code if we are working on a single code base. As I have said before, there are many styles. You can use LLVM, you can use Google. There are many others that I personally don't use. I mainly use the Google style in my projects, but if I'm working on a new project in a new team, I am going to adopt whatever style that they are using. And it is really easy. If you mess up things, you can run a tool like Clang-format to format your code the way that your company or your organization wants the code to be formatted. So suppose we want to use the Google style. One way you can use Clang-format is to run it on the terminal like we do here. And I have to say that before you run Clang-format, you have to make sure it is installed on your system. In my case on Windows, it is installed as part of my compiler. You see, if I go in CMakeW64 and go in Ben, it is going to be available as this binary here. Let's see if I can see Clang-format. It is right here. Let's highlight it for everybody to see. You can see it right here, and I can use it. It got installed because I installed WinLibs as my compiler. So let's go here and say WinLibs so that you see everything. But I talk about these things in the starting videos in this series, so you can look at that. So WinLibs, it is a guy who is nice enough to package the GCC compiler on Windows for use. They also provide the Clang compiler. If you want, you can install it, and you will have Clang-format as part of this installation here. It is also possible to install Clang-format. If you say install Clang-format Windows, you will have instructions on how to install it. It is really easy. On Linux, you have just to use your package manager, and it is going to give you Clang-format. You can also get it as part of your Clang installation on Linux. So if I bring up, let's open my terminal. We can do that actually. So let's go on my terminal here and open my Ubuntu WSL instance. And I can say Clang-format version. And it is going to give me the version. I have it installed, and it got installed because I have Clang installed here. So if I do Clang version, I will see a version of Clang. You see on this box, I am using Clang 18. If I hop over to Windows, I also have Clang-format installed. You can see I ran the same command, and I have the version 1606 that is brought in by my Clang installation, which is part of my MinGW installation here. So make sure you have Clang-format installed before you use it. Once you have it, hop over in this project and mess up the implementation for the setName function here. Let's say we want to bring curlies here. Let's say we want to really mess it up and add these unneeded spaces, and we can use Clang-format to fix this. So let's say Clang-format, okay, and we want to say, we want to fix the person.cpp file. We want to use the Google style, so we can say style equals Google, and we specify the file, which is going to be person.cpp. If you do this, it is going to say, you gave me an invalid style. So which one is it? We said Google, we didn't say Google. So let's fix this. Google, and let's pass one dash. I think it's one dash. Let's try that. Okay, you're going to see that it is going to try and format this. You see it brought the name back, but it kept the curly on the next line, and it added a space between the function header and the curly here. So this is what the Google style does. But it put this information in memory, so it dumped it on the terminal here. If we want to fix this in place, we have to pass another flag, which is the I flag. So let's do that. We're going to format in Google style, but before the style option, we need to pass an I option, which is going to say format in place. I want you to fix my code and write the changes back in the person.cpp file. And if we hit enter, you will see that our function is going to be fixed. The things we saw on the terminal are going to be written back in the file here, which is really cool. Let's see what the LLVM format does. Let's try this. We are learning, so no problem here. Let's say LLVM and run. It's not going to do anything different. So this is one way you can do this. But passing the style on the terminal like this is not really convenient in that sometimes you want to customize how your code is going to look. You want to use Google or LLVM as a base, but you want to customize things on top of your base. And one way to do that is to pass a .ClangFormat file at the root of your project and tell ClangFormat to use the instructions in that file to format your code. And that's what we have here. If you go in Clang format, you see that we have a file that I got from the internet from this guy here, Kehan Hue, if I can pronounce the name. So you can use it if you want, or you can generate your own. But it is the format that we want to use for our project here. You can see that it is specifying that it is using C++ as the language. We are using the Google style as a base, and on top of this base, we are customizing things. And you can see why I am stealing this file from this guy. It is really tedious to set up these things. We usually have somebody who specializes in these kinds of formats. They set up these kinds of rules in the company, and the rest of us are just going to be following these rules and telling Clang format to format our code on top of this format that is specified here. Okay, now that we have a Clang format file, we can tell Clang format to use it to format our code. And it is really easy. All you have to do is to not specify the format explicitly. You tell Clang format to read this information from a file. And you say it like this, style file, and you specify the file that you want. And if you hit enter, it is going to format your things. So I don't know why it is not taking out this space. Maybe we need the 2 dashes. As I said before, setting up Clang format isn't my strength, but I am using it as an example here. So bear with me. Let's mess up the code again. Maybe put a space here, and it should put things on the same line. That's what I prepared this to do. I'm not sure why it's not doing it. Now it's done it. It's going to fix the code, and it is going to make it look other functions here. This is what you can use Clang format to do. And the problem comes when you have millions, probably not millions, but thousands of files in your project. You don't want to run this command. You need to use a tool to do this. Some people may use scripting languages like Python or Bash to do that, and it is totally valid. But if we are using CMake to build our project, we can set up a target to do this kind of dirty work for us. And that's what we're going to do in this video here. We will set up a custom target, which is going to run Clang format on all the source files in our project. And when I say all the source files, I mean all the header files and CPP files in our project. Let's see how we can do that. We will start by writing a function which is going to format all sources automatically. Once we have the function, we will figure out how to run it. The first thing we want to do, we set up a function here. The function is going to be named add Clang format. It is going to take 2 parameters. One is going to be the target name. If we add Clang format, it is going to set up a target, which is going to format our code. And that's why we need the target name here. And we need to pass the source directory containing the sources that we want to format. And the first thing we tell this function to do is to find if we have Clang format installed on our system. And the find program command is going to find a given executable. We are already telling CMake, find the Clang format executable on this computer. And what it's going to do, it's going to look in the path and see if you have anything named Clang format. If it finds it, it's going to store the path to it in this first variable that we are passing here. Because we are saying required, it is going to halt the configuration if we don't find Clang format on this computer here. That's why I told you it is required to first install Clang format on your system. Make sure you can call it on the terminal like we did earlier, and then move on to write this function here. If you want, you can go in the documentation for CMake and read about this find program. This command is used to find a program, a catch entry, a normal variable, whatever. We are interested in finding a program. If the program is found, the result is stored in the variable, which is the first thing you pass here, and the search will not be repeated unless the variable is cleared. If you try to find the program again, we want to do the search because it will be already found. I think that's what they mean here. But the point is we can use this to find if we have Clang format installed on our system. And if we go past this line, okay, let's make sure we can see it. If we go past this line, we are sure that we have Clang format installed. Now that we know that we have Clang format installed, the second problem is to find the source files that we want to format. And we will be using the file command using the globe recurse option. Let's go back to the documentation again and see if we can find the file command. Okay, so this is a file manipulation command. This command is dedicated to file and path manipulation, whatever. And if we go down, we see that we have a bunch of options. We can read, we can hash, we can write, we can attach, we can do all kinds of crazy things. But if we go down, we find file system and we have globe and globe recurse. If we click on that, it is going to tell us this globe and globe recurse options generate a list of files that match the globing expression. And in our code here, the globing expression is what we have right here. Let's make sure you can see it. It is what we have here. This is our globing expression, and it is basically saying find any CPP files or header files that are embedded in our source directory. And the source directory is the parameter we passed to be scanned for files that we want Clang format to format for us here. So it is going to pass the globe recurse option. We also have a variable which is going to contain the result of our scan. So after this file command runs, we will have all the files, CPP files and header files stored in this variable here. And we can conveniently pass this to Clang format to be able to format everything in our project. This is really cool. Once we pass this file command, now comes the time to format our code. And we will set up a custom target, which is going to run a Clang format for us. That's what we want to do here. In CMake, we have a command called add custom target, and it has a bunch of options. Let's go to the documentation again and see if we can say add custom target. Okay, so we have add custom target, and it's going to add a target with the given name that executes the given command. This is the meat of this command here. The main reason you set up a custom target is to run a command, and the command can really be any executable on your system that you want to run. In this case, we want a target that is going to run Clang format for us. So we will specify the name for the target, and we will specify a command that we want to run and specify a bunch of arguments to our command. The rest is really secondary to these first two parameters you pass to this command. So let's go back to our code and see what we are doing. We are saying we wanted to create a custom target. The target name is going to be target name. We are reading this from the parameter that we passed here. And it is going to run the command. The command is going to be read from the Clang format path that we found as a result of running the find program command here. Make sure you can really understand this. Notice that we are passing the I flag here, and this is going to tell Clang format to format in place just like we did manually earlier, and we will pass the list of sources that we want to format. After that, we specify a working directory. The working directory is really where Clang format is going to be run from, and we want to run it from the CMake source dir, the root directory where we have our Clang format file. After that, we will pass a command that is going to be printed out when you run this add custom target function here to let you know what is going on. So this is really what is going to set up our target. And the main job for this target is to run Clang format for us. Let's go back in our code and actually try to do this and see what we have. At this moment, I have the code for this function in a module, but let's not confuse you with modules yet. So we're going to copy this code and put that in our main CMakeList.txt file before we call the include thing here, because I don't want you to be confused. We will talk about modules in a minute. So let's copy the code again, because I think I lost it for some reason. So let's bring that in and go to our main CMakeList.txt file. We are doing everything we did earlier, but now we added a function which is going to format our code. And this function is going to set up a target, a custom target, which is going to format code for us. Let's go down and call the function. You see we are calling it, and we can comment this out because we don't want this to confuse us. And we can try to build the code. Let's go down and set up a build directory, make dir build, and we can tell CMake, you can specify the source directory like this. And what we want to do here is to configure our project, pass the build directory. It's going to be the build directory. If we do this, it is going to configure our project using the default compiler on this system. Once you have your project configured, notice that we have a custom target. The target name is going to be format code. That's what we are passing here. So we can tell CMake to run this target specifically. Because it's not going to run by default, it's not going to be part of the all targets that we have talked about in a few previous videos. You have to run it specifically. How do you run it? You specify that you want to run this target here. Let's mess up our code again, just like we did earlier. Okay, so we can move these things here and really make it ugly. Now we want to tell CMake to run our format code target. Let's go down and say CMake-Build, and we want to build what we have in the build directory, but we can specify a target by using the T flag, and the name of the target is format code, if I remember correctly, with a dash in between. So let's say format code. We can say this, and I want you to see what happens to these lines if we build this target here. So I am going to hit enter. Okay, it's going to do its thing. It's going to check the build system. You see it's running clang format on the sources that we have in here. And you see that the code has been fixed. Okay, let's hit Control Z here and run this again so that everybody can see. If we run this, it's going to format our code, and you will see it formatted as soon as the target finishes running. You can see that we are really fixing our code here. This is really cool. Now we have the function. Let's go back to it and make sure you can see it. I really want that you can use CMake to automate things. That's why we are looking at this custom target thing here. Again, we are finding this program, which is going to be clang format. We know it is going to be named clang format because we read the documentation. Once we find the program, you're going to scan our source directory for header and CPP files. If you are using other extensions, things like HPP or CXX, you can add them here. After we have these files, we will use all the information we have to tell clang format to format our code. We pass the clang format path that we got as a result of running the find program command, and then we pass our sources, and by default it is going to be using the clang format file that we have here. If you want, you can say style file like we did manually, but this is not going to change things. Let's try to do this again so that you know I'm not lying. So let's do that. Go back and mess up our file again. So let's do something like this and rerun the format code command. Let's wait for it to finish. And you see that our code is going to be fixed. If you want, you can put this here. If you want, you can leave it out. I am going to leave it out here because it's really useless. And here we have a command running as a custom target in our CMake project. You don't have to run a clang format all the time. You can really run any utility you want as a custom target. And this is really cool. Okay, now that we have seen this, I want you to see that you can actually attach this target to be run as a result of running another target. For example, if you want your code to be formatted automatically, you can tell CMake to run this target after it builds the rooster binary. You can add it as a dependency to the rooster target that we have in our program here. You can do something like this. Now, if we do this, this is going to be built every time we build the rooster binary. If you want, you can go in the documentation and look at add dependencies, but in CMake, I think you can hover over this and it is going to give you a short description of what it does. It's going to be add a dependency between top level targets. Okay, it is what it's going to do. And if you want, you can read this in the official documentation. But now what I want you to see is that we don't have to build this target explicitly to get our code to build. Let's do that again and mess up our code. Now, if we build rooster, which is the default target in our program, we will run the clang format target as a result of that automatically. Let's try this. We're going to say CMake-Build, and if we do that, you see it's going to also run this target automatically. We don't have to specifically specify it. But sometimes you don't really want this because formatting code can be a resource-intensive task. So what I like to do is to leave the option for the users to run this target explicitly when they want to format code. The last thing I'm going to show to you is that you can wrap the code of this custom target function in a CMake module. And a CMake module is really nothing else than a script that you put in a folder in your CMake project. It is a convention to name the folder that contains this script, CMake, as you see here in my project. So I set up a script, I called it clang-format.cmake, and I copied and pasted in this function. Once you do that, the other thing you need to do is to tell CMake where to find these scripts. And you do that by appending their location to the CMake module path variable. So that's what we are doing here in the main root CMakeList.txt file. We are appending the location of our scripts to the CMake module path. Once we do that, now we will have the option to include that clang format script. So we can say include clang format. Okay, that's the name. And now we can include it. And if we build our project, we will see that it is going to be built. Let's build the target again to format the code and see if things work nicely. If we didn't break anything, let's see if it formats our code. Let's move this to the next line and do this again and see if it's going to fix the code, because you want to test your things as much as you can. Okay, it is going to fix the code. We didn't break anything. And this is really how you can set up a CMake module. In this video, we learned about custom targets. You can use the add custom target command to set up your custom target. And the main job for this target is to run a command for you. And the command can really be anything. And this is really, really powerful. The second thing is that you can wrap your code in a module and include it to really organize your code, and that's going to be really cool. You also can use the add dependencies function to tie your targets together so that when the rooster binary target is built, you also run your custom target, if that makes sense for whatever it is you are trying to do. Before we wrap up the video, let me show you what will happen if we don't find this binary. So we can go in our code and, for example, let's say we want to find clang format X, and this is something that is not going to be found. Let's see what happens if we try to build the project. Okay, and it's going to be rerun is newer result. It's going to regenerate. This is going to work. But if we go in the build directory and remove everything, so this is working because we had a cache build. So let's remove that and go back to our code again and reconfigure. How did we configure? We run this command to configure, and it is going to run into an error. It's going to say configuring incomplete, and it is going to say error at CMake. This location here could not find clang format path using the following names, clang format X. It can't really find this. So if you don't find the program, your configuration is going to halt. This is what I want you to see. But we are smart. We can fix this. If we fix this and configure again, we are going to write our build files to the build directory. We can build CMake, build, and it is going to build everything. But it is not going to build the custom target because we didn't add it as a dependency to the rooster target. But if you want to run it, you can say, I want to run this target here, format code, and it is going to run. How cool is this? This is all I had to share with you in this video. I hope you found it useful. If you really like this video, please like, share, and subscribe to support me. If you have any questions, please share in the comments below. Let me know what you think. If you have a suggestion for a video you want done in the future, please let me know. I am going to stop here in this video, and I will see you next time.